So identification of need. Now in this case, all these things I will provide you these slides also and specific notes also to you. So there is a theory question, or there will be theory question actually based on this design procedure. So in that case, you have to explain each and every step which you have seen in the previous slide, in this slide. So one by one, if you write the description for that like this, that first point is identification of need. If you are going to develop any new product, if you are going to design new product, at that time you are going to identify what is the need of that product, whether the society or people are in need of such type of products. So it can be just feeling that the weather useness, or that product is useful or not. So we have talked a lot about this. Next is that definition of problem. Once you are going to identify a particular need, uh, we are taking a such practice in Proctor also, that we are taking existing problem and we are writing the 10 existing product, and we are writing 10 problems in that existing product. So we are not bothering about how that will be, what actually we need in that product, that we are going to write as a problem statement. So when we are going to create that particular need, if when we are going to identify that need, then afterwards we are going to define that problem in well manner. That is nothing but, if suppose we are going to, or we want to come to the college from bus stand. Coming to the college is our need. Then we are defining that problem. I want to go to the college, and what are the sources which are available with me. So we are defining our problem, that I want to go to college, and what are the sources, or what are the source for that traveling. So this problem you have defined. Later on, you are going to find the alternatives. Once you are able to find, or once you are able to define that problem, then we can go for the alternative solutions. So that alternative solutions can be costly, or they may be expensive. Let it be. We are going to choose the suitable one, but we are going to make the list of the optional solutions after defining the problem. Then we are going to create proper synthesis for that. What the synthesis mean? That proper arrangement to transmit the force and power from one place to another place, and we are going to create the desired output from that. So that is called a synthesis. Like for example, we have designed forward link mechanism. In that mechanism, when we are going to find out the dimensions of that link, and when we are going to calculate how much input angle you are going to provide and what output you are going to get, if you are going to find out that relationship in any forward link mechanism, then we are going to say that synthesis is completed for that forward link mechanism. And later on, this forward link mechanism, as we are going to utilize in certain application like wiper of the cars, or this forward link mechanism is converted into a single slider crank mechanism. And if you are able to find what is the crank angle and how much displacement we are getting for the piston, if we are able to find out this relationship, and if we find the dimensions of all links, then it is called a synthesis of that slider crank mechanism. So likewise, once you are going to define that problem, you are going to find the what will be the mechanical synthesis, what will be the mechanism for that. That is how many links are required, what will be the what are the motions of that link, which joints you are going to use, and which type of input you are going to provide to that, and what output you are going to get. So
Hello, sir.
yes.
Sir, some
Yes,
students are waiting.
some students are waiting. I am allowing to everybody. See, on my window,
Okay,
nobody
sir.
is there.
Sir, they are not able to join.
Why?
They are saying you are not allowing. I don't know
No,
what is the
no.
problem.
See, I am allowing to everybody. So once again, ask them to join.
Yes, sir.
Huh. Okay, can I continue?
Yes, sir.
Okay. So when we are going to find such type of mechanisms and their dimensions, we are going to call it as a synthesis. Okay, sir, students are waiting. Okay. So that synthesis is find out. Later on, we are going to have the analysis. Now, this analysis part, which is the part of application development, that part we are going to learn in throughout in this remaining units. And this analysis is nothing but simple stress analysis. And by means of the stress analysis, what we are going to calculate is the dimensions. And that dimension when you are going to once you are going to find out, or rather than we can say dimensions when we are going to find out, then we can draw a drawing, detailed drawing for that. And that drawing can be provided by adding some features into that drawing. That is nothing but limits, speeds, tolerance, then machining symbols. Then at the design stage only, we are going to decide which type of manufacturing process can be used for that component. All these things are done after the analysis. And one more thing is that optimization. If it is required to optimize for some cases, like we have taken an example of aeroplane, in that weight is optimized everywhere. Every time we are going to consider that weight. For that, we are going to compromise some other parameters of that component. Like when we are going to consider the components which are used in luxury cars. In that case, we are not bothering about the cost. We are bothering about the safety features as well as aesthetic look of that. Then ergonomics, that person should feel very good while he is riding through that car. So all these things we are going to consider. We are not bothering about the cost. But once you are going to design car for middle class people, or once you are going to design that car which can be offered by middle class, or again we can say lower middle class, like for example Nano, Tata Nano. They have optimized everything for the cost, and they have make certain changes accordingly. They have optimized, then material is used less, then processes are reduced, everything. But they were optimizing that product for the cost. Likewise, it is called as optimization. It is true for every product, each and every product which is coming in the market, which is coming out of the company. For that product, optimization has done. Even today also, if we are going to see the mobiles, then mobiles are also designed and later on are optimized. For what they are optimized? For the features, then for the size, then for cost, everything. Okay. So at a time we can take one parameter for the optimization and we can change the other parameters according to that. That is called as optimization. So analysis and optimization is done. After that, evaluation is done, whether that product is suitable. In this case, once you are going to design everything, then prototype of that product is done. That is, testing is done for the testing, not actually testing. After evaluation, we can say it as a testing. But the product is manufactured. Its prototype is manufactured. And then afterwards, it is evaluated that for what purpose we have designed it, whether that purpose is solved by that product or not. And whether we are going to get the desired output, whether we are going to get the required things as we have considered while designing of that product. So again, in some cases, reliability, then economic validity, then everything is considered. That is profitability, likewise. Okay. So these parameters are considered and we are going to evaluate that particular product. For example, why? Because this Mercedes-Benz or Rolls-Royce or that higher-end cars are having high cost. Ferrari, we can take example, because they are going to manufacture that particular model and later on they are going to test it. They are going to hit that car as it is to the tree. They are going to simulate actually that actually they are not going to hit to the tree by they are hitting to the wall, or they are going to cut that car. What the changes has taken place after the hit, they are going to check, they are going to find, and they are going to put some dummy models also into that, and this cost is added in that product actually. So evaluation is done at this stage, and after evaluation it is put into market, or it is put in front of my higher management, so that production can be done and that product can actually launch into that market. And later on then that product is going to uh, yes, any problem, after that that product is utilized by the society. Okay, so these are the stages which we have seen. uh, you can say one theoretical question may be there based on this design procedure. Next point is type of loads. That is various types of load against which we are going to consider safety as well as stress analysis. Already I have told you that what we are going to do is that we are going to find out the dimensions of component by considering stress which is developed in that component. Also, the stress is developed because of the application of load. So first of all, we are going to consider which type of load will be applied on that component. Then because of that load, which type of stresses will be developed, because you are knowing the types of stresses, that is tensile, compressive, shear. These are the types of stresses. Okay, and if the combined stresses are there, then that combined stresses we are going to utilize one theory, and that theory is the principal stress theory. You know, Mohr circle or all that you might have drawn. So that principal stress is calculated, and that stress we are going to consider as the stress which is responsible for failure of that product, or that stress has to be sustained by the component which we are going to utilize in any machinery. So here we are going to see against or which load we are going to consider for designing of that component. So basically, there are three types of load. Later on, again we can have the subcategories of that load. But here we are going to have basic three types of that load. Out of that, first load is called a static load. In static load, this load actually is not going to change its value with respect to time. That type of load you are going to call as a static load. For example, if we are going to mount any machinery on foundation, then that machinery is not going to change its place unless and until we are not going to change it. So the load which is applied by the machinery on foundation, that load is called a static load. Or sometimes we are going to design such a products where the application of load is static. That is, the value of that force is not going to change with respect to time. That type of load is are called as static load. Any other example you can you give? You can unmute. Other example is that when we are going to design a sheet or bench, suppose in class if you are sitting, and when we are going to design that bench, when we are going to find out dimensions of that bench, definitely you are going to define problem first, then you are going to create the sketch after all that stages, and you are going to manufacture a prototype, you are going to test it. So while calculating dimensions at that stage, what we are going to do is that we are going to consider that how much weight will be applied. Weight, that is nothing but again it is a force. How much weight will be applied on that bench, and that maximum weight you are going to consider, that force is applied on that bench, and it should sustain that load. It means that the stress which is developed in that bench or the platform of that bench, okay, it should able to carry, it should able to sustain stress which is developed by the externally applied force. And once you are going to sit on that bench, frequently you are not going to change the place. So that type of load can be called as a static load. Or when you were sitting in chair, at that time, for some cases, if you are not moving your body, then we can consider it as a static load because it is not changing with respect to time. Okay. And once it is removed, when you are going to come out of the class, once it is removed, its value will become 0. There will not be any load. Okay. So that type of load is called as static load. Then second type is repeated or fluctuating load. This repeated or fluctuating load is nothing but the load which changes with respect to time. For example, if we are going to consider the reciprocation of engine, then in case of reciprocation, first of all, while we are having compression stroke, at that time, force is applied from connecting rod to piston. And when the power stroke is developed by the engine, then force is applied exactly in the reverse way. So on the piston, which type of load is coming? Because it is changing second by second. If it is compression stroke, then force is applied in the upward direction. If it is power stroke, force is applied in downward direction. It means that the force is changing in reverse way. Okay. Or it is a repeated cycle of force within the given span of time. It is not case that once you are going to have the compression stroke, engine will remain in the compression stroke only. Likewise, any engine will not run and we cannot get the power. You can imagine if the engine is running with 300 RPM, that is 300 revolutions per second, and if it is two stroke, that means in each stroke power stroke is there, each cycle or each rotation of crank power stroke will be there. Then 300 times in a minute that power stroke is developed by the engine. That means the 300 times in minute that force is going to change its value from negative to positive or from positive to negative. Somewhere it will become 0. So that type of load is called as fluctuating load. And this fluctuating load is responsible for a failure, and that is called as sudden failure, or the failure which is occurring because of the repetitive or fluctuating load. That failure is called as catastrophic failure, or sudden failure will take place well below the stress for which you are going to design or for which that product is designed. So we have to consider that load, and according to that, we have to design such components where possibility is there that fluctuating load may come on that components. Third type of load is impact type of load. Now this load, for example, we can take earthquake. Earthquake is the impact type of load. Okay, for few minutes it is going to repeat itself. Okay, again it can come go to the category of fluctuating load, but every time it is not coming. That earthquakes are not happening every time. Once in a decade, once in 50 years, that is going to happen. So that type of load is called as impact type of load. Or if suppose we are going to hit car to a tree, that load which is coming in very few seconds, the amount of load is very high. Force which is applied on the car is very high. In case of accidents, such type of impact loading is done on products. We can consider product as a car also, or two-wheeler or commercial vehicle. So in that case, impact load is coming. So it has a high initial stress, and later on, after impact, that stress may get reduced. Applied force may get reduced. But initially it has very high amount of stress or high value of stress. So this type of load is called as impact load. Okay, these are the types of load for which we are going to design components, mechanical components.
Sir,
Yes,
screen is not visible.
screen is not visible. Just a minute, just a minute. What happens? Let me check. Is it visible now?
No, sir.
No, sir.
No, sir.
Okay. It is because of the net problem. I'm trying to rejoin from the screen. Just a minute. Now, are you able to see the screen?
No,
Not yet?
not it.
Just a minute. Now?
No, sir. Hi,
Now
visible.
you may be able to see the screen. Am I right?
Yes, sir.
Okay. So we are moving to the next slide. Next point is factor of safety. Now here we have to understand what the concept of factor of safety is. Before going to this point, let me ask one question. That suppose we are going for the visit, industrial visit, as we go every year for, I think, every semester, which is included in our syllabus, industrial visit. In that case, suppose we required 1000 rupees for everything while you are leaving from college or from your home and we are coming back to your home. If we required 1000 rupees, how many rupees you are going to take with you? Anyone can unmute and give answer. How much money you are going to put in your wallet? If requirement is of 1000 rupees, everything you are going to consider, fooding, lodging, then traveling, then other expenses which we are doing over there, all these things we are going to consider. And it requires 1000 rupees. How many rupees you are going to put in your wallet?
1300 to 1400.
1400 to 1500, right? So you are going to keep more than the requirement. So if that 1400 rupees divided by 1000 rupees, we are going to take the ratio, it is coming as a 1.4. So 1.4 is called as factor of safety. You are going to keep that factor of safety as a 1.4. That means required is 1, but you are keeping more than that 1, that is 0.4 is more. But while we are calculating that factor of safety is calculated as the allowable stress or force or money in our case divided by required, that is 1000 rupees. Now in this case we are going to consider as a money, but we can consider it as a stress, we can consider it as a load also. So that you are going to consider factor of safety. Somebody will say, no, I will keep 2000 rupees in wallet. So how much factor or what will be the factor of safety of that particular student? That will be 2000 rupees divided by 1000 rupees. That will be 2. He is going to keep factor of safety as a 2. In some cases, it maybe required more than two. In what we can say critical applications, where that component is going to play a very vital role, very important role, and failure of that component may create disaster. In that case, we are going to keep higher factor of safety, that is more than two. For example, in safety cases of cylinder gas, we are going to keep that factor of safety as a 5 also, because once that get fail, it may create disaster. So we are not going to take any chance, and we are going to keep that factor of safety as high as possible. So it is written that good design engineer must consider so many factors when designing a part or component. He has to consider so many things. Like we have seen in the previous slides, how many points we have to consider while designing any new product. So out of that, perhaps one of the most important qualities to be considered when carrying that part or product is safety. That is nothing but when we are utilizing that particular product or that part in machinery or anywhere else where that or for the purpose for which it is designed. In that case, the safety of human being or safety of other things which we have to take into account safety of all that products, all that human beings. And that is most important, maybe probably more important point in all other points which we have considered. So this factor of safety is the thing where we are going to take care of all the safety features of that product. So this factor of safety usually refers to one of the things which is given in following. That is actual load bearing capacity of structure or component. We are going to consider that actual load carrying capacity or load bearing capacity of that component, or the required margin of safety for the structure or component according to the code. Now here I'm going to say this code, law, or design requirements. Now these code words come because we are utilizing IS codes also. We cannot design some components without taking prior permission and testing of government, Indian government. For example, if we want to launch new version or model of car, then it has to be tested by VRDE, that is Vehicle Research and Development Establishment. That testing facility is available in Ahmednagar. Are you able to see screen?
Yes, sir.
Okay, again that light problem is there. So let it be. I will explain it. So when we are going to consider that safety features or when we are launching a new product, at that time some code of conducts are there, and that code of conducts should followed, and later on that product can be launched in market. For example, that code of conducts or that codes are related to the safety. Nowadays we are listening that we are getting BR4 cars. Sorry, BR6 cars. Nowadays 4 is 4. We have to just stop utilization of that BR4, but we are going to get the BR6 cars. So what that BR6 means? It means that some emission problems are there, or some emission standards are there, which are followed by that particular engine of car. And if it is not followed, then it is against the code which has developed, which has released by government, and we cannot go against that code. Atharv, are you able to see screen?
No, sir. Now it's not visible.
Now it is not visible.
Uh,
Okay. So what we can do, Can we stop here for some time because of the electricity issue?
Sorry.
You be in this meeting, I will rejoin. I joined. Are you able to listen me?
Yes, sir.
Okay. So in few minutes, I will share a screen. So basic concept of factor of safety, whether you have understood the basic concept of factor of safety. We'll have
Yes,
some,
sir.
yes. So likewise, if we are going to calculate stress in any component, then whether we are going to keep that stress as the stress which is developed, which will be developed in that component. While we are going to consider the stress for analysis, so whether we are going to keep that value at higher side or will keep as it is or to the lower side. Who will give answer? What value will put for the stress?
Working stress.
Working stress. Whether we are going to keep that same value or will consider somewhat little bit higher value of stress than working stress. Rohit.
Higher value, sir.
Higher value. Okay, Atharva has given answer higher value. So what is your opinion, Rohit? You are given as a working stress as a answer. Yes, Rohit. Are you going to keep somewhat higher value than the working stress? If suppose working stress are 100 megapascal, then how much you will consider? How much means whether it will be higher than the 100 megapascal or lower than the 100 megapascal?
Higher, sir.
Higher. Okay. So here we can consider that the factor of safety will never goes below 1. Because what is the factor of safety? Already we have seen that the allowable divided by actual. So allowable you are going to keep at higher side. If suppose we keep that stress as a 120 megapascal, and if the working stress are 100 megapascal, then we are going to take ratio of 120 divided by 100. It is coming as 1.2. But if it is coming less than 1, if it is coming 1, it's okay, no problem. But if it is coming more less than 1, which is not possible anywhere in designing, we cannot design such a product which has factor of safety less than 1. Am I right? So we are going to consider that factor of safety as a above 1. So this is applicable everywhere while we are going to designing any component. And in sometimes we are going to consider the stress value, or sometimes we are going to consider as a load value, or sometimes we are going to consider as a uh, particular stress. If you are talking about the load, then working load, we are going to calculate how much load will be coming on that component. And while designing dimensions, or while we are calculating dimensions of that component, we are going to keep that design load as a somewhat higher load than the working load. If we are going to consider stress, then there may be tensile or compressive stress, or there may be shear stress. So out of that, or there may be other type of stress also, that is torsional stresses may be there. So out of that all stresses, we are going to consider designing stress as a higher value, and we are going to calculate the factor of safety. That's why it is possible to give some warranty period to various products by the companies. Otherwise, that part may get fail in its first utilization only. But as they are faithing on design engineers, as their design engineers are going to keep some factor of safety, that's why they are going to give warranty on any product. So just a minute, I'm going to rejoin and I'm going to share the slide. I'll take care henceforth for such evidence, as I don't have backup. By the way, on this point also, where we may face theoretical question in university exam. We are going to see in details what is the factor of safety and what are the parameters which are affecting on that factor of safety. I have actually shared assignment booklet and study material also. You can check in that Google Sheet and you can use it. Why is it taking time? By the way, time being, you can ask some of your questions. Is there any question? Hello? Are you listening me?
Yes, sir.
Yes, sir.
Okay. Do you have any question now? The part which we have covered.
No, sir. No, sir.
You understood it? Okay.
Yes, sir.
Very good. Very good. So you will be able to face some of the questions related to the that stages of design, as well as some of the question related to the factor of safety. How much time it is going to take? So till Now we have covered 2 points from our syllabus. Shortly, we may move further. This is not good at all. I have to take care of this all things. And one more thing, whether some of you are taking notes. Hello, or just
Yes,
you
sir. We are
listening
taking notes. No, sir.
only?
Taking notes. Sir.
Okay, okay. Because finally, I'm going to share this presentation also. But before that, if you stick any point, if you like any point, just you can note down it. And if you have any question also, you can just note down. You can ask it later on. Because all these concepts are very important while you are graduating as a mechanical engineer. We are facing problem. Network is having problem. Just a minute. Now, are you able to see screen? Hello?
No, no, sir.
No, sir.
Not
No.
yet. Is it visible now?
No, sir.
No.
Here it is showing that screen is visible. See, please see now.
Yes,
Now
yes,
it is
yes.
clear, sir.
Visible, sir.
It's visible now. It's taking much more time. Can I get at least 5 minutes? Or shall we stop here? Huh?
Yes, sir. Only 3 minutes remaining.
Pardon?
Only 3 minutes remaining, sir.
Okay. So I'll take presently first. Total 51 students are there. This is very low strength from A and B division. Okay, it's over. Thank you very much.